Hey there, students. In this clip, we're going to be going over an example on how to integrate using the method of partial fraction decomposition. We're going to be using shortcuts to the partial fraction decomposition method. We're going to be using a method called the heaviside method. Um, heaviside method. So let's consider the following problem. Question number 1. We're to evaluate the definite integral from um, 1 to 2 of the function x minus 4 over x squared minus 5x plus 6 dx. Okay? All right. So the goal here is to decompose this fraction. Let's try and see if we can decompose this. So first thing we're going to do, let's extract this fraction. We have x minus 4 divided by x squared minus 5x plus 6. Let's focus on the denominator and see if we can factor the denominator. Okay, so if we want to factor the denominator, we can use the AC method for the x game to factor the denominator. Let's see. Um, AC is 6 and B is negative 5. And then we can see that negative 2 and negative 3 work here. Okay, so we can put that in the numerator. In the denominator, so we're going to have x minus 4 divided by x minus 2 times x minus 3. Okay, now we can use this heaviside method anytime the denominator can be written as a product of linear factors. Okay, so this is a linear factor, this is a linear factor, hence we can use the heaviside method to decompose this. Okay, so what we're going to do is write this as this equal to a over the first factor, x minus 2, plus b over the second factor, x minus 3. Okay? Now we're going to multiply both sides of this equation by the LCD of the denominators, which is x minus 2 times x minus 3. So if I multiply this entire equation on the left by x minus 2 times x minus 3, it's as though I'm cross multiplying, right? So you can view it that way. I'll multiply that by that, and on the right side, I'll multiply this entire equation by x minus 2 times x minus 3. If I do that on the left side, I'll be left with x minus 4 equals a times x minus 3 plus b times x minus 2. We see why that's the case, because when we distribute these two factors to this term, the x minus 2's cancel out. And when you distribute it to this term, the x minus 3's cancel out, and you have this, okay? This method is also called the cover-up method because when you're looking for one variable or value of a or b, you can cover up on one of the other term in order to solve for it, okay? So let's say we want to solve for A. Solve for A. So to solve for A, we need to pick a term that's going to cause this quantity to be 0. So what will cause this quantity to be 0? It's 2, right? So to solve for A, you're going to set x equal to 2. All right, so to solve for A, you set x equal to 2. Then you can cover this component up. This whole thing becomes 0. So now you're going to focus on this term right here, this quantity, and this quantity. Okay? So if we do that, we're going to have 2 minus 4 equals a times 2 minus 3. All right? This term already got killed off because this became 0, and 0 times b is 0. All right? So if we subtract this, we'll have negative 2 equals a times negative 1. Negative 1, and you can clearly see that a is equal to 2. Okay? Now that's basically how you do it. Now, if we want to solve for b, we're going to set x to the value that will cause this quantity to become 0. And what is that? It's 3, right? Because if x is 3, this becomes 0 times a. This whole thing gets canceled off, and then you're left with the other two terms, this and the last, okay? So you wanted to do the cover-up method. We're going to set x equals 3. When you set x equal to 3, you can just cover this whole piece up with your finger, and you just focus your attention on the resulting linear equation, algebraic equation you get when you plug in 3 into these two sides, all right? So let's go ahead and do that. If we do that, we're going to have 3 minus 4 on the left equals, this becomes 0, so we drop it, b times 3 minus 2. All right, so let's go ahead and solve this. If we solve this, we're going to have negative 1 equals b. Yeah, so b is equal to negative 1. All right, so that tells us what the decomposition of that this function is. Okay, so now is this function going to be? So we have x minus 4 over x minus 2 times x minus 3. So the integral of that dx can be written using the decomposed form that we use to cover up a heaviside method to do. So this can be, we're going from 0 to 1. So this can be actually from 1 to, all right, so 0 to 1. Let me fix my limits. In the original problem, I meant to say from 0 to 1. Fix the limit. All right, so going from 0 to 1. Okay, so now we can rewrite the problem in its decomposed form. It will be the integral from 0 to 1 of a over the first factor. A, we found a to be 2, so it's going to be 2 over x minus 2 plus, and then b is negative 1, so that's actually going to change our plus to minus. All right, so we'll have minus b, which is 1 over the second factor, x minus 3. Okay, and then this whole thing, dx. So this is what we're going to be evaluating the integral of. And you can clearly see that this is very, very easy to integrate, right? So if we do this first term right here, we know that what the antiderivative of this is simply going to be um, 2 times the natural logarithm of the absolute value of x minus 2. And then if you integrate this, this will be minus the natural logarithm of the absolute value of x minus 3. And then this will be evaluating this from 0 all the way to 1. So that's basically it. Okay. So we're going to go ahead and use FTC part 1 to finish off this problem. So let's put in the upper limit of integration first. So we have 2, have a natural logarithm of the absolute value of 1 minus 2 minus the natural logarithm of the absolute value of 1 minus 3 minus 2 times the natural logarithm of the absolute value of 0 minus 2 minus the natural logarithm of the absolute value of 0 minus 3. Okay, so that's basically what you have. Let's simplify this. This becomes 2 times the natural logarithm of 1, because this is negative 1, absolute value is 1, minus the natural logarithm of 2. Okay, 1 minus 3, negative 2, absolute value that is 2, minus 2 times the natural logarithm of 2. And then you times this minus times that becomes plus the natural logarithm of 3. Okay, so we're just going to use the properties of logarithm to simplify this expression. We know that the natural logarithm of 1 is 0, so 0 times 2 is going to be 0. So that's just 0. These two are common logarithms. The arguments are identical, so we can write this as minus 3 times the natural logarithm of 2 plus the natural logarithm of 3. All right. Okay, so let's see what we can do here. We can use the power property of logarithm to express this as the natural logarithm of 2 to the negative 3 plus the natural logarithm of 3. And then using the product property of logarithms, I can write this as the natural logarithm of 2 to the negative 3 times 3. Okay, All right, and then we know 2 to the negative 3 is, this can just write this as natural logarithm of 3 over 2 to the third is 8. Okay? So there goes your final answer. So the integral from 0 to 1 of x minus 4 over x squared minus 5x plus 6 dx is equal to the natural logarithm of 3 over 8. All right, so there goes your final answer. So thanks so much for taking the time to watch this presentation. Please feel free to subscribe to my channel and post a comment to let me know what you think. You can always click like if you like this clip. More clips can be found on mathserve.com/calculus. Thanks again for watching and have a wonderful day.